So look, today we're looking at Glencoe Accelerated Math, Lesson 5-7 on solving proportions. When we were looking at unit rate, we talked about the fact that to find the unit rate, we could either divide or we could use a proportion. And I asked you to solve a couple problems using the proportion to get into that habit. Well, today we don't have a denominator of 1 somewhere. Of the 4 possible numbers, 3 of them are going to be something that are other than 1. So simply dividing is not going to work this time. If you just divide, you're going to get the wrong answer. Okay? So we have to do it using that proportion. And we're starting on page 218. Proportions really come in handy when trying to determine something like how many sets of something you need based on the number of people that are available. Okay? So for example, if you know that you need, if you're having people over to your house to watch the Super Bowl, and you know that generally speaking, if there's 3 of you together, you drink 5 Sprites. Okay? But instead of having 3 people over, you're going to have 26 people over. You need to know how much of that drink you need to have on hand. So using a proportion can help. Now, those are little easy numbers, but sometimes they're a little bit more difficult. Okay? So, you need to... We're going to go ahead and look in our book at example 1B. On page 218, it talks to you about vocabulary, and we've kind of become familiar with that vocabulary before. We know what a proportion looks like. We know that it's 2 fractions that are set equal to each other. We know that cross-multiplying says that you multiply a numerator times opposite denominator, and you set those equal to each other. So let's go ahead and look at a couple examples to see what we're going to do. If we are looking at example 1B, we are given 3.2 over 9 being equal to some number n over 36. Now, well, in this example, yeah, we know that 36 is a multiple of 9. They're not always like that. Okay? Proportions really come in handy when things aren't good multiples of each other. So, the first thing that we're going to do is cross-multiply. I like to draw in my Band-Aids because my proportion is broken. There's a number missing. What do we do to fix something? We stick a Band-Aid on it. That tells us that I need to multiply 9 times the variable n, set that equal to 3.2 times 36. 9 times n we simplify to be 9n. 3.2 times 36 is what? I know I've got some handy dandy calculators out there.
115.2.
115.2. Alright? Now I need to divide both sides by 9 because that is the variable, because that is the number attached to my variable. My 9's will cancel, leaving me with the variable n being equal to what? In a handy dandy calculator, I have 115.2 divided by 9 giving me
12.8.
12.8. Again, we're looking at example 1B. Proportions are unique because they combine fractions and rational numbers with algebra and solving equations. What questions do we have? No questions? Okay, you guys are going to do the next one. And tell me what to do. Look at example 2. Look at example 2. Can someone please read example 2 for me? Go ahead.
The wait time to ride a roller coaster is 20 minutes. When 160 people are in line at this rate, how long will it take? How long is the wait time when 220 people are in line?
Okay, so this is example 2. So I'm comparing the wait time to the number of people, correct? Alright, so what is my wait time that's given?
20 minutes.
And that's for how many people?
160.
And we're trying to find out how much time, I'm going to use the variable x, for how many people?
220.
220. Now, here, we know that 9 times 4 equals 36, and we can multiply 3.2 times 4 to get 12.8, correct? Okay. What can I multiply 160 by to get 220? You can't. So we have to use a proportion to solve. Okay? Does that make sense? Yeah. So, what do I need to do first? No.
Cross multiply.
I need to cross multiply first. I like to draw in my band-aids, you don't have to. Okay. What? They're abstract bandages. Okay? They're abstract. When I cross multiply, make sure we're focused. When we cross multiply, what am I multiplying together? What's my first line of work here going to say? Equals what? 160 times x. So does it matter which side of variable's on? No. As long as you keep the same quantities together, it doesn't matter. Okay? It doesn't matter. What's 20 times 220?
4,400.
And that equals what? 160x. Then what do I need to do? Someone else that I haven't heard from. Yes, sir. Just this side? Okay, but I only divide one side of my equation? I need to divide both sides. If I don't divide on both sides, then I get some number saying that we're equal to 160x, and that's not true. Our equal sign works like a balance. What we do to one side, we have to do to the other. And while, yes, we understand conceptually that we're just dividing here, and that we're going to be left with x, if you don't show it, it doesn't matter. You have to show it. Okay? All right. 4,400 divided by 160 is... Do you have it? What? That equals what? X. Now, in the first proportion, please stop. In the first proportion, we weren't given any units, we weren't given any context, we were just given numbers. In this example, we were given a word problem. So we have a context, we have units involved. What does that 27.5 mean? What are we trying to find?
How many minutes you got wait?
Right, we're finding out how many minutes we're going to wait to ride this ride. So to put this back into the context of our problem, we would say that if there are 220 people in line, we can expect to wait about 27.5 minutes. Does that make sense? So sometimes we have to be able to understand how we put it back into the context of our problem. All right? If you look back up at the proportion, because we put our units in the proportion, not just the numbers, that will help. Because our minutes need to go numerator, numerator, people would go denominator, denominator. Okay? We have to keep that consistent. We can't flip-flop units on one side compared to the other. Now let me ask you this. Does it matter where our variable is?
Maybe.
There are 4 places in a proportion. You need 3 numbers. 1 variable. Where those 3 numbers are, where that 1 variable is, does not matter. So we could have been told that we could have been given the 27.5 minutes and asked to find how many people you could expect to have in line. Does that make sense to everybody? You can flip-flop it. If we're given a problem with just numbers, we can have a variable over here too. Now, generally, because of the way that our minds put things together and organize things, the information we're given is we're generally going to put over here. It doesn't have to be. As long as you keep your units together, we're good. Okay? Questions? Alright, I want us to look at one more example before we go on. Alright, we're going to look at example 3. Example 3. Someone please read for me example 3. Go ahead.
Miss, I don't know. Paying $30 for students visit. Find the cost for 20 students.
Okay? Now, we have another example where could we multiply 4 times 5 to get to 20? Yeah. So technically, could we multiply 30 times 5 to find out our answer? Yeah, we could. But the lesson's on proportions. Okay? The lesson is on proportions. So we're going to use a proportion. We have someone that predicted that the answer was going to be what? Okay? So let's solve using a proportion and double check. In the book, it recommends that we find the unit rate first, and then we use the unit rate to put that into a proportion to solve. Do we have to find the unit rate first? Do we need to find the unit rate first? No, because we know that it's proportional. So we can set it up as a proportion. Let's go ahead and do it that way. Alright, so we paid how much for 5 tickets? $30 for 4 tickets. We need to know how much money for how many tickets? 20. What? So we are changing our thought to 150 instead of 180. Okay? Let's double check using a proportion. What's the first thing that I need to do? I need to cross multiply. When I cross multiply, what does my first line of the algebra work look like? Someone from a different group. I've heard from your group. What do we need to do? Somebody from this group, do you know? I need to multiply it, okay? So what am I going to write down to show my work?
30 times 5.
And that equals what?
600.
Okay, what goes here?
4x. Or no, yeah, 4 times x.
Okay. So, we need to show what we're multiplying first, then we can simplify. Okay? And I'm going to recommend that you write out both sides before you start to simplify. Otherwise, what I found is that we write 30 times 20 equals 600 over here, and then we never quite get the other side written down. And then we make mistakes. Okay? So, that simplifies to be 600 equaling 4x. What do I do next? This group here? What do I need to do? By what?
By 4.
Why am I dividing by 4?
Because 4's, I remember because 4's on that side, and you divide by 4 to get x.
Okay, so we're going to divide by the number that's attached to our variable. Okay? So here we divided by 9. 9 is attached to my variable. Here we divided by 160. 160 is attached to my variable. Here I'm dividing by 4 because 4 is attached to my variable. What is 600 divided by 4? Handy dandy calculator, people. Yes. Okay. So, we're saying that for 20 tickets to the museum, it's going to cost $150. You got it correct. Again, this was one where we could take 4 times 5 to get 20. But could we do that if we needed 22 tickets? We'd have to use a proportion instead. Or you could use a decimal, but we could always use a decimal. But let's use the proportion. Because the chapter's on proportions. Let's use a proportion. But you don't want to. I understand that you don't want to. And I understand that you are finding ways to do it in your head. But I'm telling you that in the chapter on proportions, we're going to do it as a proportion. Okay? You don't have to like it. I just have to know that you know how to do it. Sound fair? Okay. Any other questions?